Ever wondered why snakes are so venomous? It's a fascinating story of evolution, survival, and some seriously potent chemistry. For a long time, we thought venom was all about defense. A snake bites to say, back off. But the real story is much more complex, and it all starts with a snake's dinner. Imagine being a snake. You don't have hands or legs to grab your prey. You have to swallow it whole. But what if your meal, a speedy lizard or a feisty rodent, fights back or just runs away after you bite it? That's a huge problem. You've wasted energy and you're still hungry. This is where venom comes in as the ultimate evolutionary superpower. The story of venom likely begins in the mouth of ancient lizards, tens of millions of years ago. It didn't start as a deadly weapon. Instead, it was probably just slightly toxic saliva. Think of it as a primitive form of digestive juice. When these early reptiles bit their prey, this special saliva would get into the wound. It might have had a mild effect, maybe making the prey a little groggy or starting the digestion process from the outside in. Even this small advantage was a game changer. The lizard that could slow down its prey, even slightly, was more likely to get a meal, survive, and pass on its genes. Over millions of years, natural selection took this simple concept and ran with it. Through random genetic mutations, some snakes developed saliva that was a bit more potent. These snakes were more successful hunters. They caught more food, grew bigger, and had more babies. Their offspring inherited these venom-enhancing genes. This cycle repeated over and over again. In an evolutionary arms race, the prey would develop resistance, and in turn, the snakes would develop even more powerful venom. It's a classic example of coevolution. So, the primary purpose of venom isn't defense, it's predation. It's a tool to quickly and efficiently subdue prey. A venomous bite is like a hyper-efficient fast food delivery system. The snake injects a cocktail of complex proteins and enzymes that go to work immediately. This isn't just one single substance. It's a highly sophisticated brew, customized for the snake's specific diet. Let's break down what's in this cocktail. We can broadly categorize venom into two main types, though many snakes have a mix of both. First, there are neurotoxins. As the name suggests, these target the nervous system. They work by blocking the signals between nerves and muscles. This can cause paralysis, starting with the limbs and eventually reaching the diaphragm, leading to respiratory failure. For the prey, it means it can't run, can't fight, and eventually can't breathe. It's a terrifyingly effective way to immobilize a meal. Cobras and mambas are famous for their potent neurotoxic venom. Then we have hemotoxins. These toxins wreak havoc on the circulatory system. Some hemotoxins are anticoagulants, preventing blood from clotting, which can lead to massive internal bleeding. Others do the opposite. They're coagulants that cause the blood to clot inside the veins and arteries, creating blockages that lead to heart attacks or strokes. Still other hemotoxins are cytotoxins, which directly destroy cells and tissues. This is what causes the dramatic swelling, discoloration, and necrosis you see with bites from snakes like vipers and rattlesnakes. This tissue-destroying effect has a secondary benefit for the snake. It starts predigesting the prey from the inside out, making the meal easier to swallow and process. What's truly mind-blowing is how specific these venom cocktails can be. A sea snake's venom is designed to work instantly on cold-blooded fish. A rattlesnake's venom is tailored to take down warm-blooded mammals like mice and squirrels. Some snakes even change their venom composition as they grow. A juvenile snake might eat lizards and frogs, so its venom is optimized for them. As an adult, it might switch to hunting mammals, and its venom changes to become more effective against this new prey. It's like a chef changing their spice rack based on the main course. This incredible diversity in venom is a goldmine for scientists. By studying how these toxins work on a molecular level, we can learn so much about our own bodies. How do nerves talk to muscles? How does blood clotting work? Snake venom provides a key to unlock these biological mysteries. And this leads to one of the most amazing paradoxes in nature. The very substance designed to kill is also being used to save lives. Think about it. A hemotoxin that causes blood to clot uncontrollably could, in theory, be studied to develop a drug that stops life-threatening bleeding. Conversely, a venom component that prevents blood from clotting could be the basis for a new medication to prevent heart attacks and strokes in patients with blood clotting disorders. This isn't science fiction, it's happening right now. One of the most widely used classes of blood pressure medications, ACE inhibitors, was developed from the venom of the Brazilian pit viper. Its venom causes a drastic drop in blood pressure in its prey. Scientists isolated the compound responsible, modified it to be safe for humans, and created a blockbuster drug that has saved countless lives. Other venom-derived medicines are in development or already on the market for treating everything from chronic pain to heart disease and even certain types of cancer. We are literally turning a weapon into a cure. So, the next time you see a snake, remember it's not just a scary creature. It's a marvel of evolution, a master chemist, and a living library of potential medical breakthroughs. The evolution of its venom is a story of survival, a deadly dance between predator and prey that has unfolded over millions of years. It began as simple saliva and evolved into one of nature's most complex and potent biological weapons. And by studying it, we are learning not only how to survive a snakebite, but also how to heal ourselves. Nature's deadliest secrets might just hold the key to our future health. Thanks for joining us on this journey into the world of snake venom. If you found this as fascinating as I do, hit that like button and subscribe for more deep dives into the wonders of the natural world. See you next time.